Alright, welcome. This is Chapter 4, Part 1, and this is going to be reactions in aqueous solutions. So, in order to talk about reactions in an aqueous solution, we first need to define what an aqueous solution is. It's a solution that uses water as a dissolving medium. Now, when we talk about a solution, we're talking about two or more substances in a homogeneous mixture. So one substance is going to be in greater quantity than the other, and it's called the solvent. Okay? Smaller quantity is called our solute. The easiest example that I can explain is salt water. Right? We have a lot of water and a little bit of salt, and so we say salt is dissolved in water. So one of the questions we can ask is that why is it that we can't bring our hairdryer or our big boom box with a tape player and CD player sitting on top, like I used to have at least? Why can't we bring those into the bathtub that is filled with water, right? Well, we know that water doesn't conduct electricity alone, right? It's actually the substances that are dissolved in water that conduct the electricity. And so the substance that is dissolved in water determines if it can conduct electricity. So we know salt will, but sugar won't, even though they're both colorless and they're both clear. So if we take a look at the figure shown down here, right, we can see that with pure water, the lamp doesn't come on. With a sugar solution, same thing, the light does not come on. But when we add in salt, like sodium chloride, the light turns on. Well, we know to turn that light bulb on, we need some kind of current, right? And a current is just electrically charged particles which move around between the two electrodes. Okay, in pure water, that's not going to happen, right? And so a substance that will dissolve in water and produce ions is what we call an electrolyte. A non-electrolyte, the substance may dissolve in water, but it does not dissociate to ions, and that's key. So ions are what conduct the electricity. So if we first take a look at ionic compounds in water, all right, and we think about in an aqueous solution, we know that ions are present, okay, in an ionic compound, right? These ions are electrically charged particles that can flow from one electrode to another and complete that circuit. So when salt dissolves in water, like sodium chloride, we get sodium ions and chloride ions. Okay? If we put sugar and dissolve it in water, no ions are going to be produced. Okay? It's a non-electrolyte. The difference between the salt and the sugar is the fact that salt is the ionic compound, while sugar is a molecular compound. So water will dissolve ionic compounds easily because it's electrically neutral. Okay? But the oxygen carries a partial negative charge, shown here in red, while the hydrogens are going to carry a partial positive charge. So cations like sodium, right, shown here in purple, okay, is going to be attracted to that partial negative charge of the oxygen in water, okay, and anions like chloride, okay, are going to be attracted to the partial positive end of water of these hydrogens, right? And what we call this is called solvation, when water molecules basically pack around that ion. And a lot of times you'll see this as being denoted as AQ, which means it's aqueous, it's been solvated. Well, when a molecular compound dissolves in water, the solution contains intact molecules which are just dispersed throughout the solution. So here you can see methanol is just kind of dispersed throughout. They aren't really solvated by the water molecules. Only a few molecular substances have aqueous solutions that will contain ions, and we call these acids. Okay, we'll talk about these in the next video. Well, electrolytes can be divided into either strong or weak electrolytes. A strong electrolyte is going to ionize completely. That means 100%. These are going to include things like the ionic compounds, your strong acids and strong bases, which we'll talk about later in this chapter. And weak electrolytes are going to ionize partially, so less than 10%. And so really, how can we classify the difference between a strong and weak electrolyte? If I gave you some sample and I said, is it a strong or weak electrolyte, you could probably use a flow chart like the one shown here in order to determine that. So that concludes part 1. It's pretty short. There's 2 more parts, so you should watch those as soon as you can.